Hello, class. This is Mr. Kim. Um, Today is March 19th, and today's topic is solving radical equations. Now, before we begin, I just want to make sure that you understand what's going to be happening for the next week. As you know, March 27th is our last day of the marking period, and I know that I have to put a lot of grades back in for our lesson quizzes for those of you who have completed them. Yes, I've received your email, and I am going to take a look at everything that you guys have done and put you in the proper grades for that. If you guys have any questions regarding your grade, you shoot me an email. I will be more proactive in those regards. With all these crazy things happening, it was just a lot to take in. But starting from this point onwards, I'm going to make sure that what I do, whatever needs to be done to make sure that you guys have the lessons, and we do these things together, bit by bit. But it will get better as the time goes by, I promise. Now, supposedly, if we get into the school year until the end of April or even May, because the situation's dire and it's getting worse. Um, Regardless of that situation, my best priority is to make sure you guys are prepared for any concepts that they may throw at you in terms of testing in Algebra 2. Last week, or 3 days ago, when you guys were doing the assignments on Monday and Tuesday, I only gave you Pearson assignments because it was something that we have already dealt with. There were 30 questions in total. Everything was online. Hope you guys all finished it and turned it in. I'm going to take a look and just put the grade in appropriately. For quiz and tests, tests and quizzes on this stuff, we're going to be taking it on next Monday. So make sure that you guys have the knowledge for radical equations, solving them, and also how to convert from radical expressions to rational exponents. We talked about that last week, and also I gave you work on Pearson. If you guys have any further questions, just please shoot me an email. That will be the best way to contact me, even though I might be late from time to time. But I promise you that I will be more proactive from this point onwards. Okay, so let's get started on this. Solving radical equations. Everything that I'm doing right here is it's based off of the the 5-4, I believe, the chapter. It builds upon from the radical expressions and fractional exponents. So you guys have to be proficient in understanding that concept before we jump in. I'm going to go to the next slide here. Okay, and then so the first question that you will be able to see is solve the radical equation square root of x plus 5 minus 1 equals 3. I will also give you the Pearson work related for this as soon as I finish this video here. And I'll upload this for you guys to see on Google Classroom, also on YouTube, so that you guys will be able to find it. Now, for the remainder of today, what I want you to understand is how to be able to solve radical equations. And you will see something like this when you just a simple square root like that. Or you will see sometimes a cubic root like that, and you should be able to solve for these types of expressions here. Now let's go back to part A. What do I need to do first here is that you need to get square root of x plus 5 by itself. The reason for that is because you cannot solve for something like this on the top unless I get rid of this minus 1 first. That is your first and foremost priority. The reason why we have to have this by itself is because if you have, let's say, square root of x equals to 25, or square root of x is equal to 4, whatever the numbers may be on the other side, all you have to do to get rid of this square root symbol, you just have to get rid of the square root by squaring both sides. Squaring both sides. Just like that. So it's pretty much the same thing as your algebra questions where you have 2x is equal to, let's say, 4. The very first thing that you have to do is divide by 2 and solve for it, right? But if you have 2x minus 1 is equal to 4, you need to get rid of this minus 1. That's why you want to get rid of this minus 1 on the top here as well. That is the very first thing. So if I rewrite this expression, you want to add the 1 to both sides first like this. And then what you're going to end up with is 3 plus 1, which is equal to 4. Now remember, you do want to get this, whatever is underneath the square root symbol, you want to get that first. Don't subtract the 5, subtract the 5, don't do any of that stuff. Add the 1 on both sides and just get it ready. After that, like I told you before, like these steps right here, you're going to apply it right here. So if I have a square root of x plus 5, the next thing that you need to do is get rid of square root by squaring both sides like that. And by doing so, what you're going to get is x plus 5 is equal to 16, and then x is going to equal just simply 11. Well, how did I do that so quickly? Well, let me just get this out of the way. Ooh. Okay. Well, from here, you just have to subtract 5 on both sides, right? So when you subtract 5 on both sides, 16 minus 5 would be just 11. Therefore, you would be able to get the answer. Now, if you were to simply plug this back in here into the equation, square root of 11 plus 5 minus 1 is equal to 3. Well, 11 plus 5 is 16. So square root of 16, well, that's 4. Minus 1 is equal to a 3. And that should be an equal sign right here, but I can't make an equal sign because it's like right underneath it. Maybe if I just, yeah, there we go. So square root of 16 is equal to 4, but then minus 1 comes down, so 4 minus 1 is equal to 3. So therefore my answer checks. So you can always go back and check for your answers like that. Now for something like this, a cubic root of x plus 2 is equal to 4, you're going to be doing the exact same thing. Your very first step, like I always emphasize this in the class, what is the very first step that you need to do? Well, the cubic root of x plus 2 is equal to 4. The very first step, like before, is going to be subtracting 2 on both sides. Because, like I said, you want to get square root, whatever has the radical by itself. Minus 2 on both sides, cubic root of x is equal to a 2. Now, when we have a square root of x is equal to a 2, you guys all know how to do that. Because the opposite of square rooting is simply squaring, and we have done that countless times. Just because you see something like this doesn't mean that your first attitude is go, oh, I don't know how to do this, and then I'm not going to do anything about it. No. A cubic root is no different from a square root. If you squared to get rid of the square root, because they are basically opposite from each other, they basically cancel each other out. This is cubic root. Because of this radical, a small number in that index that says 3. So what we need to do is the opposite of cubic root, which means it's going to be cubing both sides. So I want to cube this side, so I'm going to raise that to a power of a 3, and raise this also to a power of a 3, and that's basically what's going to happen to get rid of the cubic root. So you cube it. Or take the power of 3, if you will. So if you do that, these two will cancel each other out, and what's going to end up happening is that it's going to be x is equal to 2 to the power of 3, which if you type that in your calculator, you're going to simply get equal to 8. So that is going to be your answer. Or if you want to think of this in a more, I don't know, fractional exponent scale or rational exponent, x cubic rooted is same thing as saying x to the power of 1 over 3. Because remember what I taught you last time was that if you want to rewrite any radical expression into a rational exponent, this is to the power of 1. So this cubic root goes right underneath it and then makes always the index number, we call this the index number, it becomes our denominator. So it's 1 over 3. So you just bring that right to the bottom here, and then that just becomes x to the power of 1 over 3. And then you would say that that's still equal to a 2, because that's the problem. Now, if I want to get rid of 1 over 3, remember, you have to raise it. It's pretty much the same thing. Raise it to the power of 3, raise to the power of 3. 3 times, well, 1 over 3 times 3, they cancel each other out. Therefore, you're going to have 1. And then you're going to have cubic on the other side. So x is equal to 8. It still gives you the same answer. Okay? Now, for the next slide, I would like you to try these on your own, and I'll post the answers for you guys to see online. So I'm going to skip this page, and please work on this. Pause the video if you want to work on this by yourself, or do whatever you need to do. Take a look at these questions and write that on a piece of paper. This is sort of like, imagine if you're in our classroom right now. This would be your guided practice, and I would love it. I need you guys to work on this on your own. Make sure you guys get these right. Remember, this is square rooted, so you have to square it. That's my hint for you. This is cubic rooted, so you have to cube it. Your first step for A is to take a look at this. Make sure you get rid of that. Next, Now, solve the radical expression square root of 3x minus 2 is equal to x minus 4. Now, the question that we're going to be presented with from this point onwards is going to be different from the question that we have seen from before. Now, why is that? Well, it's because x now is on both sides of the equation now. Well, how do I solve it? Your first step does not change whatsoever. Your first step is always to get rid of the square root. Square root on both sides by doing the opposite of it, squaring it. Now imagine if 3x minus 2 had this minus 1 at the end that was not under this roof, so to speak. It's not under that square root symbol. So this minus 1 has to go. It has to go. Because we always want to isolate, that's the magic word here, we want to isolate the square root as much as possible and then, work our way up. But, luckily I don't have that situation, so I don't even have to worry about that. Okay, so I'm going to erase that. It's already isolated. So then your next step is to simply do what we have been doing. We have to square both sides. And by doing so, what's going to end up happening is that we're going to have 3x minus 2, because these two will cancel each other out, the square root and the squared symbol, is equal to x minus 4 squared. Okay? Now, I know what you're thinking. This means that it's going to be quadratic. Yes, quadratic is going to be tough. This is why these questions are going to be the bread and butter for the solving radical expressions, because they're going to be a lot different. We have x's on both sides, and that just changes the paradigm of the questions just a bit. But please don't panic. We're just going to FOIL it. I know for a fact when you guys doing this on your homework, you're going to say x squared minus 16. I cannot emphasize this enough that please do not do that. Okay, when I ask you to FOIL something, it doesn't mean that you're going to just square, I'm going to square this. That's not what's happening. You have to FOIL it as if you're writing down those two parentheses and the first, outer, inner, last. That's what you need to do. So what's going to end up happening is that 3x minus 2 stays the same, is equal to x squared minus 8x plus 16. Well, wait a minute, you're going way too fast. Hold up, Mr. Kim, how do you get minus 8x? Well, just take a look at x minus 4 times x minus 4, and just take a look at, and we'll just break it down for you. X squared, that's first, so you write x squared. Negative 4 times x is minus 4x. Then you do the inner, minus 4x. And the last is, please, it's negative times negative, which gives you positive 16, and then that's going to be that expression when you guys just combine the middle two together, and then voila, we're done. Okay? So now I have this. And I have this on the left-hand side. Now, since part B kind of builds upon part A, I'm going to write down the work here. Your first job, your next step is to take a look at this expression. 3x minus 2 is equal to x squared minus 8x plus 16. You got to recognize that it's a quadratic. Now, if it's a quadratic, you need to understand also that you got to have the other side to be a 0. Well, how do I do that? Well, you got to move the 3x onto this side. You got to move the minus 2 on the other side, because I like to keep my x squared positive. Okay, well, maybe if I just erase this so that you guys understand this a little bit better. What I'm going to do is I'm going to move everything to one side. So I'm going to subtract the 3x on both sides, and I'm going to add the 2 on both sides like this, and they will cancel each other out. So what's going to end up happening is that this entire side will be 0. And the other side would be simply, the x squared comes down. Negative 8x minus 3x is minus 11x. This is plus 18. This, yes, it can be factored. Oh, I don't know how to find the two factors of 18. Well, just take a look. It's 9 and 2. And when you add them, what do you get? Yes, you get 11. Since that's negative 11, what you want to do is you want to write x minus 9 and x minus 2. Sorry guys for factoring, I don't want to spend so much time on it. You guys, it has to just come out right away. So what's my solution going to be? Well, x minus 9 is equal to a 0. X minus 2 is equal to a 0. So solve for it. You add the 9 on both sides. You get x equal to 9. Add the 2 on both sides. You get x is equal to 2. And therefore, you're going to get those two solutions right there. Now, if you read the question, because this is really important, x equals to 2 in the question right here. X is equal to is an extraneous solution. Oh my goodness, we have to deal with this extraneous solution again? Yes, absolutely. For rational and radical, expressions, you will have, or you will most likely encounter these things called extraneous solutions. So how do we deal with those? Well, like before, you just have to plug it in. So what is going to be your last step when I always ask you guys for radical expressions? You guys told me that it was going to be double check your answers. Make sure you plug it back in. For radical expression, it's going to be the exact same thing. You have to plug it back in. And now why is that so important? Well, because if you plug something in into the radical expression, you guys know that square root of a negative number cannot happen. So that's what we're going to be checking for. So I'm going to just take all of this out. Okay, and I'm going to start working from here. So I have found my solutions, and I'm going to work from here. X equals to 9, and then x is equal to a 2. And then I am simply going to plug in x is equal to 9 into this equation. So let me rewrite that for you. Minus 2 is equal to x minus 4. Square root of 3x minus 2 is equal to x minus 4. And then I am going to take the x equal to 9 into the equation here and here. Plug in the x equal to 2 into here and here. And notice what's going to happen. If you plug in a 9 into here, you get 27 minus 2 is equal to 9 minus 4. Square root of 25 is equal to 5. And yes, that's, you guys all know square root of 25 is going to be a 5. Now the problem here is that if you plug in a 2, it's going to be 6 minus 2 square rooted is equal to 2 minus 4. Now square root of 6 minus 2 is square root of 4 is equal to 2 minus 4, which is negative 2. Now, some of you guys might be wondering, oh, wait a minute, isn't square root of 4 like plus and minus 2? No, it's not. When x squared is equal to 4 and I ask you to solve for it, that's when you say, oh, I have to take a square root of both sides, so x equal to plus and minus 2. When you get square root of 169, square root of, I don't know, 81, square root of 4, they all just end up being 13, 9, and 2. They are all positive numbers. So square root of 4 cannot equal negative 2. That's why it's called an extraneous solution. Okay? Just like before, most likely, whatever gives you the negative numbers, that was the magic cube. So that this is the reason why you want to plug it back into the original function and make sure you check for those what we call extraneous solutions. Okay? So plug it back in, make sure everything is positive. Okay? Square root of 25 is just positive 5. Square root of 4 is just positive 2. But since it's not positive 2 and it's negative 2, that's why we don't call this a solution, and we only say that x equal to 2 is an extraneous, while x equal to 9 right here will be the real solution. Okay? Try to solve each equation, so please try these as well. Whenever it says try it, I want you to do it by yourself and make sure that you're able to do this on your own. What's your first step? Like before, the very first step is always to get rid of the square root on both sides. So I hope you have this in check. The rest, I will leave it to you. Your last step, please keep in mind, it's to not, oh, Mr. Kim, x is this and x is that. Because I guarantee you run into quadratic. But you remember, check for the answers. Plug it back in, please. I cannot emphasize this enough. Check and plug it back in. Okay, the rest of it here, I am going to, let's see. For right now, I'm going to stop here and then make sure that you guys have the video. For these questions here, I'm just going to leave you guys for it to do, but we'll probably work on this next time, okay? So up until here, when we're asked to solve for the radical expressions, I think that's going to be good enough for today. I'll give you homework assignments and make sure you're only doing what you're learned for today. Okay? Hopefully this video was helpful, and make sure you have questions, just email me and I will get back to you ASAP, or try to get back to you ASAP. And I'll see you next time on Monday, or tomorrow I'll also upload a video for you guys to do part 2 of all of these other questions. Most likely it's gonna end up happening at the end of the day, but we'll see what happens. Thank you very much.